Okay. How's everybody doing? Good. Make sure the stream is going. Okay, cool. So, we've just got more predicate logic, obviously. Any questions, anything we want to go over? Is anybody struggling? All right, how are we doing on, like, the translation part of this so far? Are we able, like, have you guys been able to do the homework, like, without getting completely stuck on, like, the translation bits at least? Okay. So let's focus on proofs then. Is that okay with everybody? Okay. Any naysayers if we just do proofs and don't practice translations right now? Okay. So let me open up. Where is everybody at in the homework? What's the last chapter you did any work on? If you're behind, it's okay. No judgment. I just want to know where I should start. Let's just call it out. What's the last chapter you did any homework in?
I'm on 8.2.
8.2?
I'm working on 8.2.
Yeah, that's okay. So let's do... Let's start in 8.2. I'll tell you what, we'll do translations and then do the proofs as well. Let's do a couple together first with the document camera. The projector is like totally out of work. There we go. Focus, you cretin. Come on. Oh, come on. I'm gonna have to get rough with this thing. Let's go. What the heck? Look where it's focusing at. It's like 2 inches from the lens. Looks like the last professor broke this. Come on. Does everybody have their books? Okay. Looks like the document camera just isn't going to work today. Unless... No, it is the camera itself. None of its controls are even working. Okay, well now it won't turn off. Cool. Die. Alright, never mind. So turn to 8.2.2, and we'll just have to read aloud, and anybody watching at home is just going to have to follow along with their book. So 8.2.2, let's just go down the list together as a class. Alright, so 8.2.2 number 1. Oranges are sweet. Also, oranges are fragrant. Therefore, oranges are sweet and fragrant. Alright, I want us to start thinking, if we're not already comfortable with, everything you hear. What is this? It's a big ass wasp. Everything you hear, I want you to think in terms of all, some, for every, at least one, right? Because those are what our quantifiers mean, right? So when you're reading these normal person sentences in the book or anywhere else, try to translate it in your head and use the words like all, for every, for any, at least one. There is some, right? And that will be the key to how you know how to translate it. Does that make sense what I'm saying? Okay. So 1, oranges are sweet. Also, oranges are fragrant. Therefore, oranges are sweet and fragrant. So we already know premises, right? I won't make us answer pedantically, but premise 1 is oranges are sweet. Oranges are sweet. What does that mean? In terms of our vocabulary I was just talking about. If I say oranges are sweet, is that all oranges are sweet? Is it some oranges are sweet? Is it any orange is sweet? How would you guys put it?
I'd say all.
All? Yeah. How would you symbolize all oranges are sweet?
For all x, there exists an x that has property O and an x that has property S.
So, for all x, I don't know, I'm putting parentheses on my quantifiers. For all x, there exists an x such that x has property O, and
Sorry, I just mean for all x, like x is O and x is S.
okay, yeah. I was just putting this up here.
I just said it wrong.
Yeah, no, you're good. So for all x, x is O, and x is sweet. Is that what you're saying?
Yeah.
Okay. So read this to me, and what does that say?
For all x, x is orange and x is sweet.
Mm-hmm. Do you see any problems with that?
Yes.
What is it?
That x could be like an apple or something.
Right, yeah, not, this literally says for anything that exists, it's a sweet orange, right? Yeah, but that's not the case, or, I mean, maybe it is. Are we all oranges? I don't know. So what would I do instead of the and here to fix that?
I'm not sure.
So think about what you'd want to say in this language. For any x, x is an orange makes x sweet.
Oh, an arrow?
An arrow, good, or a horseshoe. So for any x, take it away from here. What's it say?
If x is an orange, then x is sweet.
Good. You see how that fixes it? So again, when we're talking in terms of universals, the universal quantifier, typically, if you see something like all dogs are mammals, it's going to have an arrow to it, right? Okay. There's other ways to symbolize it, of course, because we know that arrow is equivalent to an or and a negation, right? Or you do De Morgan's on that, you could get ands. But typically the easiest way is just to use an arrow with these type of things. Okay, so 2, all oranges are fragrant. all oranges are fragrant. So what quantifier do we think that is? Universal. So, okay, so for any x or for all x, and then its oranges are fragrant.
You just did what you did on line 1, but replaced the S with an F.
Good, yeah. So for any x, if x is an orange, then x is fragrant. Good. All right, conclusion. I'm going to model this because we're going to do a proof on it like that. Where am I? Oranges are sweet and fragrant. What quantifier?
Universal.
Universal. So for any x, if x is an orange, then what?
Sweet and fragrant. So
How would I symbolize it?
SX dot FX.
Good. Good. Okay. So how can I do a proof on this? Remember that we have restrictions. Make sure the camera's focusing. Remember that we have restrictions of our rules. So we've got, what are our 4 rules I've covered in class? Generalization, instantiation, but what types? Someone list 4 of them.
You have universal instantiation, universal generalization, and then existential instantiation and existential generalization.
Good. So universal instantiation just goes like this. If you know that for any x px, you can conclude PA. Or, if you want to keep it super general, you can conclude PX, right? And the reason I say that is because when we get into the generalization part, if I go from having a free variable, right, without a quantifier, from this, I can generalize back out to everything. Okay, so that's the restriction there. Do you guys remember that one? Okay. What about existential instantiation? What's that one?
So, existential instantiation is your instantiating the statement with at least one thing that does exist. So you can't, like your restriction on that is you can't do it. You can't put a variable in there that already exists.
Good, good. So we can go from there exists an x such that x is p to picking a name for it, a, but the restriction, I'll just call it rest, is must pick new name, right? Can't be a name that's occurred previously. Universal generalization. I guess I'll put the restriction must only generalize out from free variable. And again, a free variable is just one not bound by a quantifier, right? It's free because it's not bound by a quantifier. I'm worried that that thing's going to kill me. I'm not really that scared of wasps, but I really don't like being stung. From a free variable that you derived from universal instantiation, right? Existential generalization. If I have PA, I can generalize out to there exists an X such that X is P. Any restrictions on this one? None. The restrictions are just on universal generalization, existential instantiation. Does anybody need a refresher on why we need those restrictions? Okay. So let's do a proof here. Should be fairly simple, right? How can I get started on this proof? We already know that for any x, if x is orange, then x is sweet. And for any x, if x is orange, then x is fragrant. So we know this follows, right? For any x, if it's an orange, it's sweet and fragrant. But how do we show it in our symbolic proof method? How can I start doing this? There it goes. Oh no. Is that a cicada killer or a wasp?
That's a
No, it's an actual wasp. Huh? Cool. How would I do this?
Quick question, I know you'd use universal, but when do you know when to use UI or UG? Does it matter, or
What do you mean?
like this one, would I use, like how do I know which one's better to use? If that makes sense.
I want to leave. I can't do bugs.
I'm gonna get stung. Oh shit. You get him? You stun him? Someone step on him quick, finish him! He's dead. We did it! Yay! Poor wasp.
Good job.
You know, like how some people have arachnophobia and they're irrationally afraid of a flex spot? That's me, but with like anything that's flying and yellow.
Yeah, I mean, you really, like, you did a move, man. You're like,
I
whoa!
almost got in a wreck the other day because I was driving and I just looked down and there was a wasp on my leg. And I almost flew it onto my tree.
Oh man, I had never been stung by a wasp until I moved here, to Stillwater, and I'd been stung by bees as a kid, but you don't have that many wasps, like big wasps in California. And the first few months we were living here, I was wearing like basketball shorts. I was about to go to bed. I walked outside to take the trash out. I came back in. I just like felt something on my leg, but like inside my pants. And I sat down and I just like, holy shit, like 5, just immediately like, I just started getting stung like crazy right on my bare butt. Like, because it somehow crawled in my pants and just kept stinging me. It sucked. Yeah, I hate wasps, but that one hurt real bad. Couldn't sit down for a few days. Anyway, sure you wanted to hear your teacher got stung on his bare butt by a wasp. Okay, how do we...
Do you always have to start with UI and then go into generalization?
Okay, so it depends what your goal is, right? So you can't just, let's say I have PA here, right? I can't just generalize from that. Why? This is a name for a particular object, right? Why can't I do this? Why doesn't that work? Why is this philosophically bad?
Because you don't know what it is, because it's already, the A is already established, I guess, and then that's just kind of.
The A is, yeah, a name. A is a name for a particular thing, yeah. But why can't I go from A has property P to all things have property P?
Because it's not all things.
Yeah, it's
You don't
not all
know if you're
things.
referring to everything.
Right, yeah, this is referring to everything and anything that I could find in the world. So I can't say from one particular object that I know everything, right? You can't go, one thing is A to everything is, or I'm sorry, one thing is P to everything is P, right? So the only way to get a universal generalization going is if I already have something that's supremely general. That is, I start out with this, right? I instantiated it using a free variable, x still, and then now I can, no matter how many steps, as long as I remember that's where I got this from, I can generalize back out.
Yes.
Does that make sense? Yeah. And now, this philosophically makes sense Because getting rid of this is just a way that I could use my proof rules without having to invent a bunch of new rules. I'm not really making this particular. Does that make sense? Okay. It's kind of like how, you remember conditional indirect proof, you're like, assume for the sake of argument that this thing is true. This is basically saying, assume for the sake of argument that we can talk about this without the quantifier.
Okay.
Does that make sense? Yeah. Okay, so if I'm starting with universal quantifiers here, where am I going to go? You can see it.
And we can keep X?
Yeah, you could keep X, you could use X, Y, or Z for your free variables that you instantiate with to keep it general. So A through A, B, C, D, E, F, G, H, I, J, K, L, M, P. Fuck. A, B, C, D, E, F, G, H, I, J, K, L, M, P, Q, R, S, T, U, V, W. Why couldn't I think W? I don't know. You could use everything A through W as names for particular objects. X, Y, and Z are going to be these free variables. So the only thing we could do here is universal instantiation, right? So who wants to pick, how do I instantiate this and with what letter? You'd use X, Y, or Z. You want to do X? Sure. Okay, so I'm going to drop the quantifier on 1. I'm going to drop the quantifier on 2. And because these are universal, they apply to everything, right? So I can just be instantiating for the same object. Okay, what do I do from there? Now this is just our normal proof, right? So what rules can I be using to get this conclusion? I could use conditional or indirect if I want to, or I could just do it straightforward with our normal 18 rules. Anybody know how?
Maybe conjunction?
What?
Conjunction?
Sure, let's conjoin it. So we'd have OX, sorry. And then SX and OX, then FX, 3 for conjunction. Where do I go from there?
Material implication.
Yeah, on both sides? Okay. So what would that give me?
Not OX or SX. And then not OX or FX.
5 implication.
Can you do distribution?
Yeah, what do you want to distribute?
The not OX outside parentheses. And then 4. Is that distribution? I can't remember what it is.
Again, distribution's my worst rule. So we wouldn't be able to, right?
This is one of the ones that the book gives you. They do not OX or in parentheses SX and FX.
Yeah. So, say that one more time.
So they go not OX right after the one that you have right now. They go not OX or in an open parentheses SX and FX close parentheses.
Right,
And they
okay, yeah,
use
yeah.
implication again to get it back to
sorry, it takes me a minute to do the distributions, my eyes just don't like them. Wait, what am I doing? My God. Right? You bet?
Yeah.
Yeah. Yeah. Having a brain freeze. All right, good. I hate that rule. All right, now what do you do from there?
You use implication again to,
Good.
to do OX implies SX.
Beautiful. All right, last step.
Then you do universal generalization.
Okay, why can I do that here?
Because we chose an arbitrary X whenever we first instantiated it.
Good. We chose an arbitrary X, and we're keeping track of these X's have all come from those arbitrary instantiations here. So now we know we can get back up. So there is I don't know, I've never found a good, easy way to somehow like mark it. Exactly how to keep track of where each of your letters come from. What I always used to do is whenever I'd instantiate something, I would just underline the variables where I'm getting them from in different colors. But that's a lot of tedious work, right? So if you can just remember it, that's fine. Has anybody come up with anything to keep track of these things yet? No, you just have to remember, I guess. Yeah. Okay, and there's our conclusion. So good. And then that's 8 universal generalization. Right. On the longer ones, it does help to have some way to remember exactly where you're pulling the X from. That's why, since we can use X, Y, and Z, I would say use X to instantiate when you know you're going to have, let's say I want to use these for 2 different purposes. Use X for one of them and Y for the other one. Does that make sense? Yeah. Just do something so you don't get lost. Any questions on this one? Okay, let's jump a few ahead. Let's do number 5, 8.2.2. Beans are peas and legumes. There are no legumes in the garden. Therefore, there are no beans in the garden. Beans and peas are legumes. There are no legumes in the garden. Therefore, there are no beans in the garden. Speak for yourself. I have plenty of beans in my garden. All right, how do I say 1? Beans and peas are legumes. Let me ask you this. Existential universal quantifier. Raise your hand if you think it's universal. Raise your hand if you think it's existential. Okay. So it's universal quantifier. How do I represent this?
Would it be for any X, an open parenthesis, if, so XB or XP, and then, or, yeah, so if XB or XP, then XL, or LX, sorry.
Extra large bean, please. Yeah, okay, so this says, for any X, if X is a bean or a pea, then it's a legume. Sound right? What's another way to do this one? I'm just going to put it off to the side here. How else could we do this? For any X, Anybody think?
You could break it up into two different statements.
Good. How would I do that?
That'd be bx implies lx.
So if x is a bean, then x is a legume,
And then
and
if then it'd be x px then lx.
good. If x is a pea, then x is a legume. See how that's the same? Now we'd have to do quite a bit of work to prove how that's the same, right? Because we do a couple steps. But they're the same in terms of meaning. Anybody see a different way to do it? Using two quantifiers. I'll give you a hint. The first part is for any x, if x is a bean, then x is a legume, and what can I do after that?
Can you do for any x, if x is a p then x is a legume?
Yeah, you could do for any x, I'm just gonna be super clear and do y. For any y, if y is a p, then y is a legume. Now it could be x because these x, if I write it like this and they're both x's, they don't overlap. This x is ranging just over this, right? So it would be safe to do that, even if it was for any x this, there exists an x this. Does that make sense?
Out of those three options, which one would you say is the easiest to work with? Like, which one should I shoot for when I'm trying to help with?
It depends on your proof. Yeah, so if you have a proof that two conditionals would help you because you can see you can do modus ponens quickly, start with this one. These will be pretty much equivalent. All that will differ in your proof is that you'll have to do one more instantiation and generalization, right? To get that y out. Does that make sense?
Yeah.
This you just instantiate once and you have something for everything, right? So, I mean, they're ultimately all the same. They're all equally right. This one, in my mind, is the simplest. But that's just because I like arrows and I hate anything but arrows. But this one makes perfect sense too. So I'd say it's between these two a tie. Just depends on what you want. Any more questions on this? Okay, so how do we do two? There are no legumes in the garden. Is that how you say it? Do you say legumes? Am I pronouncing it wrong?
I think that's right.
How do you say legumes? Say it.
Legumes.
Say it.
Legume.
Legume. Same.
Okay, just making sure.
I vaguely recall in a Disney movie one time someone pronounced it as legume.
Yeah, my
It was
wife's
dramatic.
family pronounced it that way. I'm like,
I think that was just to be dramatic for this.
yeah, maybe they're just dramatic. There are no legumes in the garden. How do I say that? There are no legumes in the garden. There ain't no legumes in the garden. Raise your hand if you think it's a universal quantifier. Raise your hand if you think it's existential. I got one.
Well, it depends on where you place the negative.
It all depends on where you place negative, right? Good. Because as I already showed you, and I think this is 8.3, this is the same as this. This is the same as this, right? So yeah, you could use either depending on the negative. How do we want to do it though? Somebody tell me what to write. There are no legumes in the garden. You guys are so shy and quiet. But you're the only ones who come to class. It's a paradox. Okay.
I have no idea.
Okay. So what does it mean to say there is none of something?
There's not one.
There's not one. There's not even one, right? Okay, so just forget legumes in the garden. How can I symbolize there's not any of them?
There does not exist in that.
Does not exist in X, such that X has some property P, right? There isn't even one. The other way I could do it is, for any X, it's not PX, right? Because anything that exists isn't going to be a P. All right, so now if I say, there are no legumes in the garden, the first thing is going to be, let's just say, there is no X, there's not even one X, such that what?
X has property L and X is in the garden.
So X is a legume, and how do you want to say in the garden? Is the garden a particular or a general thing? The garden.
It's a particular.
It's a particular. I don't know which garden, but the garden means there's some single garden I'm talking about, right? So what would I say? Would I make the garden a property, or would I make it a name for a particular garden? What do you think?
It gives you a capital G as one of your predicates.
Yeah.
So would that be a property?
It would, yeah. So there's multiple ways to model this, right? And the book, I'm not saying the book is wrong. I am saying the book is only giving you one presentation of this. So what if we take it as a particular, the garden, it's a particular object or area, what would it be symbolized as? Would it be a property or a name? A name, right. So here's the first way of doing it. The property I is inside. X is inside G, the garden. The garden. There isn't anything X, such an X is a legume, and X is in the garden. Right? Make sense? Book doesn't want you to do that. Why doesn't the book want you to do it? Well, have they taught you in 8.2 two-place predicates yet? I thought they did. Where you've got relations. No, that's 8.6. Well, I've taught it to you sooner, so we could do it like that. I think that this is the way that makes the most sense, to say the garden.
What's between the I and the G?
X.
Oh, okay.
Yeah, so that's a two-place predicate. It says X has property I in relation to G. Or X has relationship I to G. How does the book want you to do it, though? There are no legumes in the garden, where the garden is G, or maybe in the garden is G, right? How would I say that? Where in the garden is now a property.
LX and GX.
Good. Someone read this for me.
There does not exist an X such that X is a legume and X is in the garden.
Good. And now, do you see why I'm saying it's problematic to say X is in the garden is not, should not be a property? Again, maybe I'm just putting too much philosophy into the logic, right? You can call that 2-star. Therefore, there are no beans in the garden. How do I say there are no beans?
It would be not existential quantifier. And then BX and IXG.
Good. Like that? Good. So there isn't even one thing that is a bean, and it's inside the garden, right? How would I say it in this way? We'll just say conclusion start, where the garden is a property.
Then be not existential
there's not anything x such that x is a bean and x is in the garden, that whole property. Right? Good.
Does it matter which way we go? IXG or just
It doesn't matter. Very, very much.
Okay.
Does it matter for you? Probably not. Does it matter for the book? Not at this stage. Philosophically, conceptually, it does matter, yeah. Because if you're going to take this as a model of what we're saying, if someone says to you, the legumes are in the garden, are they telling you that the legumes have the property of being in the garden and not referencing a particular garden? No, it's just like if I was talking about my cat. My cat refers to an object, right? So it really does, this is the better way to put it. This is the book's way of putting it.
Is that gonna make it, so as far as homework and tests, is that gonna be more confusing or more difficult? Or do we need to learn that anyway?
So when we get to 8.6, you'll be learning this anyway.
So
Yeah.
just start it now.
Yeah, I'm just teaching, my approach to teaching is, the book takes you, these little tiny baby steps. I take the actual model of like learning a new language, and I just throw it at you and I say, we're going to intuitively pick this up. Yeah. So hopefully by the time we get to 8.6, you'll already be doing some of this, right? Now, let me ask you this. They have the same first premise. And on the final, which will be all predicate stuff, I'll give you translations to do. I'll make some of them multiple choice like I have in the past, if you remember those. But the ones I want you to do freehand, if you did this or this, I'd let you off. Like, it's fine either way, right? Okay. So, is this argument valid just by looking at it? For any x, if x is a bean or x is a pea, then it's a legume. There are no x's such that x is a legume and x is in the garden. Therefore, there are no beans in the garden. Valid? Raise your hand if it's valid. Okay. Everybody in class thinks it's valid. What about this one? For any x, if x is a bean or x is a pea, then x is a legume. There aren't any, there is not even one legume that has the property of being in the garden. Therefore, there is not any x such that x is a bean in the garden. Valid or invalid? Raise your hand if it's valid. Okay, so you see that either way it's going to be valid, right? So where this matters is in terms of how we are interpreting what somebody says. And maybe the steps on how we prove it, right? Okay, somebody walk me through, how can I do a proof for this one? Any ideas?
Would you have to rewrite the second premise as a universal?
Mm-hmm. Good. Yeah. So how would I rewrite that as a universal?
Well, you move the negation inside and change it to universal.
Like that?
Yeah.
Yeah. Now, have you guys learned this yet? I've taught it to you, right? The first day, or the first 2 days. This is about 8.3. How would you have done this, though? How would you instantiate from here without doing that? You just couldn't. Our rules don't cover anything about negations, right? So, we would have had to have the foresight to use a universal with a negation after it here. That's more complicated than just knowing how to do this, right? So that's why I teach it to you all up front. Okay, we'll just say this is a change a quantifier rule, which is 8.3. I'm just changing this quantifier to the universal. Again, kind of like De Morgan's, think of it like an algorithm. If I have x, I add a negation to both sides, and then make it the other quantifier. So if I have not x, right, I add negation to both sides, and then I change the quantifier. I get rid of my double negations, and it becomes that. I'll give you the algorithm for that too, when we get to 8.3. Actually, screw it. Change a quantifier rule. Change a quantifier. Algorithm. 1. Add negations to both sides of quantifier. 2. Flip quantifier, or change the quantifier to the opposite. 3. Get rid of double negations. Simple, right? Simpler than De Morgan's even. So if I start with this, how do I do this algorithm on it? What's it become?
It's going to become just existential because you add negatives to the before it and after it, so it's not x, not.
Good. So I add my negatives. What's step 2?
Flip it.
I flip my quantifier. I change it, whatever you want to say. And then last step?
You get rid of the double negation, so it's just.
Good. So it ends up just becoming there exists an x. It's not the case that for any x it's not the case. It means that there exists an x. Okay, good. So again, I'm just going to keep it with the algorithm. I'm not going to bother giving you the rule the book does because I think it's sucks. Okay, so we did that there. Where do we go from there?
Then you use a universal instantiation.
Do you want to do it on 1 or 3?
We're gonna have to do it on both, but I'll do one first since it's.
Do 1 first, okay. What letter you want to pick?
I think like you'd have to use x.
Yeah, that's fine. We could use x. You can use y or z
Yeah,
too.
yeah, but you do a variable.
Universal instantiation. 5.
So you'd also instantiate 3.
3, good. And then what letter? What variable?
I'd use x again.
You can use x again, yeah, and that's totally fine. And then that, you keep the negation, and it just becomes that. You're literally just, universal instantiations, when you are not using a particular name, you are literally just removing the quantifier. It's just a convention, a writing convention. It means nothing else. Okay. What now? Jillian, what would happen if I did De Morgan's on 5?
You get not lx or.
Yeah, Jillian.
I'm sorry.
It's okay.
On 5?
Yeah.
Let me do this really quick. So,
You're on a roll, so you're like, I want to answer.
so add negations outside, inside, flip it 2 and 4,
Good. You get it to an or.
and then get rid of any double negation. So it wouldn't have a negation outside. So it'd be negated LX or negated IXG.
Good, exactly. Good use of the algorithm. I love it. Okay, so we got that. Where can I go from there? if you want. I don't know if it'll get us anywhere. We can try it.
And so then from there you can do a hypothetical. So, right?
Mm-hmm. What lines?
Oh, with 4 and 7.
4 and 7.
You get bx or px implies not ixg.
So bx or px implies not ixg. Right? Yeah. Alright, so now we know. I don't have a quantifier, but we know it's general still, right? Because we got it just from a vague universal instantiation. So basically what this is already saying is any x that's a bean or a p ain't going to be in the garden, right? Okay, so I want to say there are no x's that are beans in the garden. How can I get maybe this b by itself? How can I start doing that?
Would you? De Morgan's, to make it an and
Let's try a De Morgan's.
then just do a 9 sim and drop the px. Jillian's rule.
Yeah. Can't do a simp because there's going to be a negation on the
Oh,
outside.
that's right.
Yeah. In office hours, she's talking about Jillian's rule, and I don't think I covered it in class, but she came up with a rule that does work to simplify out, to save a lot of time. And I'll let her do it. I think this is Jillian's rule. If you have square and triangle, then circle, you can just say, oh wait, no, sorry, the other way around. Circle, then square and triangle, you can just say circle, then square. Something like that. Right. There's a couple of Jillian's rules that we made. I think we got up to 3 stars on the Jillian's rule. Okay, so we can't do that here. 8 De Morgan's. Who sees what we could do? Anybody? How can we start getting this b by itself and the ixg by itself?
Would you distribute on it?
Distribute on 8?
Am I thinking about it right?
What do you mean distribute? What are you thinking you're going to get?
What's the one that I recognize it by? Wait, no, that's not right.
Exportation.
Exportation. Yeah, you can't use it yet. You have to do a couple things. And then I'm not even sure you'd be able to use it because you have a negation outside the
Yeah.
end. But that's closer. Which rule were you thinking of?
I got it wrong. I forgot the distribution is ands and ors.
Mm.
And is an and an if.
Does anybody see what we could do?
Can you do the transposition?
We could try it. On 8? Or 9?
On 9.
9. So this would be, you flip it around and negate each side, right? So, or reverse the negation, whatever you want to say. So ixg, then you get rid of that negation, you have not bx and not px. 9 trans. I'll just continue over here, 11.
So I'm wanting to do it like a conditional proof here. Because I feel like if we assume ixg.
Let's try to do it for now without a conditional proof.
Okay.
And I think that's 8.5. Everybody else but us will be confused in the watching this. How could we do this without conditional proof? So we know now that if it's in the garden, then it's not going to be a bean, it's not going to be a pea. Which Jillian's rule would get us there, but we can't. I'm not going to let us use Jillian's rule right now.
Could you use implication?
Sure, and then that would give you this. Right, 10 implication,
And then you do distribution.
and then you distribute it.
Yeah. There we go.
Right. Or,
Yeah.
is that right? See, I told you, my distribution is like the worst, it's the thing I'm worst at. $11 distribution. Okay, so now we've got these two things we know are true. Where do I go from there?
You do simplification to just get not IXG or not DX.
Good. Now, what does 13 mean?
That X is either not in the garden or it's not a bean.
Mm-hmm. Good.
Yeah.
Okay. What can I do with 13?
You could dimorphise it to not IXG and DX.
Yeah, they're all close, right?
Uh-huh.
How do I swap their order?
Is it commutativity, right?
Mm-hmm.
I always get that and associativity confused.
Me too. These are basically the same thing.
Yeah.
Okay, we're close. What do we do now?
Would you use a universal generalization from there?
Now, this is why it's hard to keep track. It's 16 lines away from where we started. I have to somehow remember that I got this x all the way from up here and here, right? That's why using the x and y's and z's are necessary here. Again, they're not necessary. The x, y, and z aren't necessary in terms of doing it right. They're necessary in terms of, I don't know how else we would keep track, right? And it's still hard. Okay, so we got this. How do we now get to this step?
Then you use the change in quantifier.
Change the quantifier. Okay, so now I'm just going to put it over here. If I have x, for any x naught, I add a negation to both sides, which becomes this. I flip the quantifier, and I get rid of double negations. It becomes that. Ignore those. So from this to that. Good. Valid. Why did I put 14? God. But valid. Good. You are all doing very well at proofs. And now we are back to baby level. This stuff complicates a lot, right? I mean, we're still better than we were before we learned propositional, but it took us a long time to do this one. Any questions? What time is it? Let's see. We got like 10 minutes. Does anybody want to go over anything before we go? Should we just call it there? Any questions? Homework problems? The extra credit argument Dropbox I opened on Canvas today. So just remember 3 arguments in English, written normally, then in standard argument form, and then translated with standard argument form into symbols, in propositional or predicate if you want. But so that was due at the start of class today. But I opened the Dropbox last night, so just get it in by the end of the day. Sound good? Does anybody have an argument they want to share before we go? No? Yes? Maybe? Alright, we can just call it there. I will see everybody later. Let me know if you need any help or anything.